Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Functional isomerism requires identical molecular formula and two different functional groups. Moving on to the next step. The first compound is butan 2-ol C4H10O alcohol, and the second is methyl ethyl ether C3H8O ether. Their molecular formulas differ, C4H10O versus C3H8O, so they are not isomers at all. Moving on to the next step. The first compound is butanol, CH3CH2CH2CHO, C4H8O, an aldehyde, and the second is butanone methyl ethyl ketone, CH3CH2CH3, C4H8O, a ketone. Both have the molecular formula C4H8O but different functional groups, aldehyde versus ketone. These are functional isomers. And for the final step, the first compound is propan 1-ol C3H8O, an alcohol, and the second is propanol C3H6O, an aldehyde. Their molecular formulas differ, C3H8O versus C3H6O, so they are not isomers. Both compounds shown appear to be esters with formula C3H6O2, methyl acetate structural isomers of the same ester class. They have the same functional group, ester, so they are positional or chain isomers, not functional isomers. Only option B presents two compounds with the same molecular formula, C4H8O, but different functional groups, aldehyde and ketone, making them true functional isomers. Therefore, the correct answer is B. Therefore, the correct answer is option B.